Hello, this is Ting Ting, and this is my final project for the Managing Machine Learning project course. So the topic I chose is Predictive Incident Management to leverage machine learning to optimize infrastructure support for operations. And let's look at the details. So my opportunity evaluation. So the problem introduction is that as a team responsible for infrastructure provisioning within a software company, our roles often resemble those of firefighters due to the constant urgency of the support tickets. And each ticket represents a critical issue demanding immediate resolution. So by leveraging machine learning to monitor and forecast potential incidents and also predict the frequency of component failures, we aim to streamline our operations, thereby optimizing team efforts and resource allocation. So to summarize, our objective here is to leverage machine learning to predict incidents and improve team capacity utilization. And I used the module one information to analyze the benefits. The first one is, does someone care? Yes. It saves costs and enhance customer satisfaction. So machine learning can significantly reduce our firefighting efforts, leading to improved efficiency and reduced downtime. And the second one is, can machine learning help solve it? Yes, definitely. Machine learning techniques can do predictive analytics and anomaly detection, which is exactly the one we need to use here. And is there a problem? Yes. Based on the frequent urgent support tickets, there is an immediate need for a solution to streamline our operations. So then going to our CRISP DM process, which is regarding to the business understanding. So first of all, our target user is the infrastructure providing team. And the problem is the team is frequently overwhelmed by urgent support tickets, which disrupt development and production activities, turning them into firefighters. And it matters because resolving this urgent issue can give us could save us a significant amount of time and effort, and thereby increase teams' productivity and capacity to focus on strategic tasks. However, the current state is the team lacks a proactive approach to identify and mitigate potential incidents, relying solely on reactive firefighting when issues arise. So if we want to measure the success of this project, some of the metrics we can look at is reduce support efforts and increase system uptime and also improve team capacity allocation. Let's say we have less capacity on the support effort and we have more capacity focusing on actually develop more features. And the relevant factors we can consider is one, historical incident data, two, system metrics, urgency level, and also teams burn down check to look at how are we spending the capacity. So further regarding solution validation plan, the solution concept is we want to develop a predictive model using historical incident data to forecast future incidents. And the validation approach will be to conduct iterative experiments by training the model on historical data and validating its performance against unseen data and refining it based on our feedback. So coming to the fun part, how do we want to do this machine learning system design? So the model selection is pretty intuitive. We want to choose time series forecasting and anomaly detection. And several system design decision will be we will do this on cloud because we need real-time data to help us do the prediction. But offline learning, we don't really need to do online learning in this case because we probably won't have a lot of disruption here. And then the online prediction is needed since we need real-time data and then real-time prediction. Several potential risks in production. One is we might encounter different types of model failures. One is training serving skill due to data discrepancy. The training data might be different from our production data. And then highly likely there will be latency with data pipeline. And then data drift in changing system behavior, like since we use different provider for the cloud infrastructure, like Google, Azure, Amazon, or so on and so forth, that might not using one of them might change the system behavior. And then concept drift with evolving user needs, we might start using Google more than Azure, then there might be increasing user needs in the GCP production. And the mitigation plan for us is we should implement monitoring tools to detect data drift and concept drift, and also establish retraining schedule to update the model regularly, and also conduct thorough testing in staging environments before deployment. That's all about my project. I'm looking forward for your feedbacks. Thank you for listening.